Question 2, the unit for the moment of the force. Well, we know that moments are the turning force. So that's the force times by the distance. So the units of force are newtons and the units of distance are meters. So that means that the units of moments must be equal to Newton meters. So that's Newton times meters, which is B. The painter sets up a uniform plank so that he can paint the wall. Alright, it's 3 meters long and weighs 500 newtons. Now I'm just going to label up some stuff on this diagram here, and that's absolutely okay. In fact, I would encourage you when you're in the exam to label directly on their diagram, because it shows that you understand what's happening, right? So I've just labelled up all of those distances on there so that I can clearly see. How did I know that it was the weight of the plank was in the middle like that? Well, if you think about it, it's a uniform plank, okay, and that means that the weight is going to act through the middle of the objects, right, which is 1.5 meters from each end, okay. So use the principle of moments to show that the upward force on A is 250 newtons. Now, look, they've told you the answer, right? Okay, so, and it's a 4-mark question here, isn't it? So they're not going to be satisfied with, anything less than a rigorous calculation here. Okay, well, the principle of moments is that the sum of the moments clockwise is equal to the sum of the moments anti-clockwise. Okay, and the trick here is just to put a pivot at some point. Okay, and it really doesn't matter what point you choose. Okay, if you choose where one of the forces are, it just makes the maths a bit easier, right? So I'm going to choose this as my pivot. Okay, and I'm even going to label it up, that this is my pivot. But actually, you could work it out for any point along the whole beam, and it would still work out, right? So now I've got to think, okay, look, I've got that distance there, that's 1 meter, okay, to this force here. Now, is that making it go clockwise or anti-clockwise? That's an anti-clockwise force, right? So I've got force times by the distance anti-clockwise, okay, and that force is 500 newtons. Okay, and the distance, which you said was 1 meter, didn't we? All right. Now, what's the other force? Oh, it's this force over here. That's force A, right? And that's making it go clockwise, right? So again, that's force times distance. Now you can see that this sum here, if there's more than one force clockwise, then I could just add them up like this, couldn't I? Yeah, I could just add them up. Okay, but in this example, there's only one force clockwise. So I don't need this term here, I can just use this term here, right? The force is what we're trying to find, so I'm going to leave that as the unknown. And the distance, okay, well, it's the distance from the pivot, right? So that distance there, okay, between there and there, that distance is 2 meters. All right, there we go. Okay, so now just do a bit of maths on that. Okay, and it comes out as 250 newtons. Okay. Is that enough to get me our 4 marks? Let's just check. Formula, yeah. Substitution, yeah. Answer in units, yeah. That's going to be good to get me my 4 marks then. All right. State the value of force B. Okay. It's a pretty straightforward one. You don't need to show any calculation here. Okay. But if you wanted to think about, why, then look, you've got force A. That's 250 newtons up. Okay, you've got the weight, that's 500 newtons down. Okay, and we've got force B, and that's that question mark there, right? Okay, now we don't need any moments here. We just need to think about Newton's first law. Okay, the plank's not accelerating up or down, so that must mean that the forces are balanced. So if there's 500 newtons downwards force on it, that must mean it must be balanced by 500 newtons upwards force on it. Okay. So the missing force must be 250 newtons. All right. Okay, painter stands on the plank as shown. Draw an arrow on the diagram to show the weight of the painter. All right, so the weight of the paint has got to be vertically downwards. Okay, and label it up. Okay, obviously you're going to draw this with a ruler. It's not so easy to do on my laptop screen, but you're going to draw that with a ruler and it's going to be vertically downwards. Okay. Nice if it starts from the center of mass of the painter, okay, but it doesn't actually have to, as long as it's touching the painter at some point. I think that's going to be okay. Describe the changes in force A and force B when the painter stands on the plank. Well, if we go back to this diagram here, okay, well, we were looking at the vertical forces. Okay, now we've added another vertical force in, haven't we? Okay, so now the vertical forces downwards are more than 500 newtons downwards. Okay, let's say that, you know, this was 1,000 newtons or something like that if it was a 100-kilogram man. All right, so that means that, you know, somehow we've got to increase these upward forces as well to balance out that 1,000 newtons. But they don't necessarily have to be equally, you know, it's not 500 on each of those. And if you look, the painter's closer to B, so that means B is going to have to increase more than A. They both increase, but B is going to increase more than A. All right, so there we go, 2 marks, one for saying that they both increase, one mark for saying that force B increases more than force A. And that's the end of question 2.